Okay, we had a question about the intermediate value theorem. So even though that's not going to be in the test, it's coming up, so we need to know something about it. Okay, if f of x is continuous, then if f of a is negative and f of b is positive, it follows that f of x is 0 somewhere between x equals a and x equals b. That's one statement of the intermediate value theorem. Now, it's going to seem like something very obvious, but when you get to the foundations of mathematics, you find that it's something that requires a lot of thought and some rigorous proof. Okay, well, that is, though, our statement of the mean value theorem. That's going to be sufficient for this course. So what does it mean? This statement can translate into what I've written down here. It says, you can't get from here to here without going through this line, and if your curve represents a function, it's got to happen in this interval. Okay, so f of x is continuous. This means that you draw its graph without taking the chalk or your pen or whatever off the paper. So we're saying you can't draw a curve that goes from here to here without going through this infinite line, not a continuous curve. If you don't want to go through this line, you got to skip over it and you got to take your chalk off the board, your pen off the paper. Now, there are ways to get from here to here when you don't go through the line within this interval. Okay? I could come around here like this and come over here. I could go around here like this. I could do all kinds of things. But if I go around here like this, then I'm going to fail the vertical line test here, because I've got to go past that vertical line, then through it again. Okay, I've got to go through the vertical line, then back through it. Meaning that I don't have a function. So, I didn't say all the words. F of x I'm implicitly regarding this as a function, but provided f of x is a function, and provided it's continuous, if you go from here to here, you got to go through the x-axis on some interval here, within this interval. Okay, so it says again, can't get from here to here without moving your chalk off the paper, without going through this line. And if your curve represents a function, it's got to happen in this interval. So, if this is the x-axis, f of x has a 0 in here. That's the intermediate value theorem. One application of the intermediate value theorem, and it won't seem like anything profound, but later on we're going to use this to do a neat little approximation of the zeros of a polynomial function. Okay, if f of x is this function, the question is there a 0 in this interval? Now that is the actual problem that came up. Is there a 0 in this interval by the intermediate value theorem? Okay, does the intermediate value theorem guarantee that you have a 0 in this interval? Well, f of -7 is negative. You plug it in. You get a negative 343 here, and nothing else is big enough to make it positive. And f of -5 is positive. -5 cubed is -125, but 6 times 5 squared is 150, and the rest of this isn't enough to bring that -125 down low enough to counter that 150. So f of -5 is positive. Now you can actually plug the numbers in and get them, but at some point, there are things you can skip. Okay, well, and since f of x is continuous, this is a continuous function, so we assert f of x is continuous, so there's got to be a 0 between x equals -7 and x equals -5. Why? Because when x equals -7, f of x is negative. That means your y value is below the x-axis. F of -5 is positive, meaning that your y value when x is 5 is positive. So you have this situation. You have a negative going to a positive, and you have this interval, in this case an interval from -7 to -5, within which you have to cross the x-axis. And that means that the function is going to be 0 at that value of x. Okay, so there it is. That's what the intermediate value theorem tells you about this function. Now, yeah, getting a little confused about where things are. You're given that the average rate of change of a function with respect to x is 2.3 on some interval where x changes by 0.5. Question is, what's the length of that interval? Well, if you put your information on a graph and think about what rate of change means, it means change in y divided by change in x, and that's just the slope of your graph. Okay? That's your rise divided by your run. So you draw a picture. You say, okay, let's see. You got some interval here, and on that interval, x changes by a certain amount, and y changes by a certain amount. The amount x changes by is the length of your interval, and the amount y changes by, well, let's see what our information is. It says the value of f of x changes by 0.5. Well, y is f of x. The value of f of x gives you the y value. And if f of x changes by 1/2, means y changes by 1/2. Well, on this interval, there's your change in y. Slope is your average rate of change. That's 2.3, because the slope is change in y divided by change in x, which is the rate of change of y with respect to x, the average rate of change. So, we've got delta y, and we know that delta y is 0.5. Slope is 2.3. That's delta y divided by delta x. The width of the interval is delta x, and that's what we're trying to find. So, delta y over delta x equals slope equals average rate of change. So, delta y being 0.5, and the slope being the average rate of change, the slope is 2.3. You have 0.5 over delta x equals 2.3, so that delta x equals, and boy, I said it wrong in class, totally wrong. Delta x is 2.3 divided by, is 0.5 divided by 2.3, not 2.3 divided by 0.5. That wouldn't make any sense, and I should have tried to use a little sense. So that's your 0.5 over 2.3, and that comes out like 0.22 or something like that. Okay, I think it does come out 0.22. You can do the arithmetic. Now a couple questions about composites. And this is pretty straightforward. I think people saw this immediately. You have this function, and you want to express it as a composite of function f and a function g. So you want this to equal f of g of x. Well, this equals f of g of x if f of x is x to the 2/3, g of x is negative 6x squared plus 6x plus 8. Okay? Then, if that's the case, just to see that that's true, f of g of x is what? F of x is x to the 2/3, so f of g of x is g of x to the 2/3, and g of x is this. So g of x to the 2/3 is just this, so that does it. That's how you express this as a composite. And one reason you want to be able to express functions as composites then is because the rate of change of this function is related to the rate of change of this function and the rate of change of this function. You just basically multiply the rate of change of this function times the rate at which this function changes at the value of this function, and you get the rate at which this thing changes. That's a big deal in calculus and a big deal in applications of mathematics all over the place. Okay, another example of a composite is log of 2x cubed plus 6x minus 9. Well, that equals f of g of x. If f of x is log of x, g of x is 2x squared plus 6x plus 9. If f of x equals log of x, then f of g of x is the log of g of x, and the log of g of x is the log of this, and that's what you started with. Another problem, you want to find integers whose difference is 46, whose product is a minimum. Well, we got to get an expression for two integers whose difference is 46. Now, some people want to use x and y. You can actually do that, but you end up with a pair of simultaneous equations. It's going to lead you to the same point. I said it wasn't going to do you much good, but I was a little bit wrong about that. It could, if you want to deal with the simultaneous equations, and many times you do. But you don't have to deal with simultaneous equations, and the setup we're going to use here doesn't. Okay, so we're going to start by letting x be one of the integers. Well, the other integer is going to be the difference of the two integers is going to be the absolute value of the other integer minus x, or x minus the other integer. And without going into too much detail, we can say that, okay, the other integer could be x plus 46. Okay? So if it is x plus 46, then we can check to see that the difference between x and x plus 46, well, that means x plus 46 minus x, which is just 46. So the difference is 46. Okay, so this is the expression. Now somebody wanted to use 46 minus x, because of course we did a problem earlier where you cut a wire into two pieces, length of the wire is 60. If you cut it so that one of the pieces has length x, the other is going to be 60 minus x. So it's real easy to write that sort of thing down, and it wasn't a bad guess, but if you check it out, it's not going to give you a difference of 46, okay? In any case, now what's the product of the two numbers? Well, one number is this, the other number is this. The product is then this number times this number. X times quantity x plus 46. You want to write it x squared plus 46x, that's fine. I worked with it in this form because it's real easy to see what the zeros are here. But also seeing this form tells you for sure that it's quadratic, so it has a parabolic graph. Okay, so both of these forms inform us of something. I'm going to use this form to find the zeros. I could use a quadratic formula here, but most likely I just factor the x out and get this, set it equal to 0. Okay, so if x is negative 46, that's a 0. And if x is 0, that's a 0. So you have a 0 here and a 0 here, and you have this parabola through the zeros. Also, the parabola opens upwards because x squared is positive here. Well, there we have it. The axis of symmetry, it's symmetric. So the axis of symmetry had better be as far on to the left of this point as it is to the right of this one. In other words, it's got to be right halfway between these points at x equals negative 23. So your minimum value occurs on the axis of symmetry because your minimum value is at your vertex. So here's your minimum. Now I kind of slopped the graph. It looks like this is a minimum, but you know what I meant. We'll just get rid of that. Okay? Okay, so here's your minimum value of y. That would be this. To get that minimum value, we just plug negative 23 in here. And I use this form, so I don't want to square negative 23 at all. I'm going to have to. You get negative 23 times negative 23 plus 46, which is negative 23 times negative 23, which I think is 529, pretty sure of that. Okay? Check my arithmetic. That's the minimum value. And I forget how the problem was posed, but the integers are x equals negative 23 and 46 minus x equals 46 minus 23 equals negative 23. Equal integers. Okay, so, yep, that pretty much does it for the problems that y'all posed for today. And good luck on the test.